Welcome to the Tech Arena Data Insights series sponsored by Solidigm. I'm Allison Klein, and today we're hosting a discussion on high-performance portable compute at the edge with Antillion and Solidigm. To join us in this discussion, we have Alistair Bradbook of Antillion and Connor Doherty from Solidigm. Welcome to the program, guys.
Hey, Alison.
Hi, Alison. Great to be here.
So why don't we just get started with introductions? Alistair, you are the CEO and founder of Antillion. Why don't you go ahead and just give a bit of a background on Antillion?
Yeah, sure. My journey started about 30 years ago, actually. I was working for a pharmaceutical company, Quintiles, out of North Carolina. And it was all about data collection in those days for patients at the edge. So my fascination with collecting data in the edge started actually very young. From that, we and my previous business ended up working in Iraq, and we did a number of years out there working with the multinational groups over there to try and deliver IT components into that space, and that got my interest even more into understanding how the human factors go into delivering IT components, hardware, software, as well as the humans around them into those difficult arenas. Now, we know that in the commercial world, the edge has become a growing topic. The edge now is much more proliferating around some of the cloud providers, pushing their capabilities further forward, and AI and machine learning is definitely growing in that space. So I suppose that's where I came from, and where we're going to, we'll discuss during this, but it's definitely around those edge environments, and that's where Antillion's big focus is around that.
Connor, do you want to just do a quick introduction for yourself?
Yeah, sure. Thank you. So I'm an FA at Solidigm, so I do the technical relationships for customers across EMEA in Europe. I joined from day one when Solidigm began back in 2020. And before that, I was at Intel, part of the storage group there, and have been a member of Solidigm since day one, supporting customers like Antillion. And yeah, being that presence in EMEA and helping with that technical education of our SSDs and our portfolio and helping customers understand the latest and greatest tech in that space.
Fantastic. Now, I am really excited to delve deeper into this topic, and Antillion has been making great inroads in terms of delivering innovative edge platforms for various use cases. Why don't we just start, Alistair, with a question of, Antillion has an interesting purview on the market. What drove you to decide to design edge servers, and what did you see as a gap in the market for this play?
Yeah, so it definitely drew out from our experience working with defense and security organizations, where 20 odd years ago, what we used to find was very old capabilities, pretty slow, very expensive, and typically very heavy. But they had the environmentals that people wanted at the edge because of the way they were using them. And we thought that something needed to change. Both the cost profile needed to change to allow more people to get access to this capability, but also actually trying to push data center technology, I suppose, is the way I coined it many years ago to some of my people I was talking to, is how far forward could we push some of the new emerging data center technologies? And that obviously was the greater core council from AMD and Intel, and the amazing technologies we're getting with storage, which Solidigm spearheading in terms of how NVMe became a big part of that capability. So we were really keen to see, could we push those technologies forward, but still make them operate, simply, because the other challenge is that often with great new technology can come complexity, and we can overshadow that when it comes to data centers, because we can put very expensive people, but there's not many of them, and they all get to sit in nice areas. When you get to that edge environment, you don't typically get those experienced people who are able to go there, and the breadth of the number of those devices obviously increases. So the key was around that simplicity. So we talk about swap a lot in my world, the size, weight, and power. That phrase, I think, is now moving more into the commercial world as well. So, and if you put a C on the end of that swap C, you actually end up then with a cost basis. So not only is it reducing the swap, it's also for us reducing that cost boundary. So that was the key elements of why we looked at, I suppose, getting into a market that was busy in the defense security sector then. Wasn't so busy when it came to the classic commercial providers like Amazon's and those sort of But actually now it's a very busy space. Everybody has some degree of capability that they're pushing towards the edge because data is being collected obviously much further forward, and that needs processing to be delivered there.
Now let's take a one click down into those edge environments because I know that the edge is one word, but it describes so many different types of environments. How do you take a look at that and figure out the design points for edge servers, given that they go into so many disparate places?
Yes, the challenge, we have edge devices that need to be on people. We have edge devices that need to go up onto drones or into smaller objects that move around. We also have what we would typically call like a forward operating base, or an area where people are going to do traditional IT capability in fixed locations, where it's like a mini rack of servers that's going to be delivering that. So we need to cover them all because one size definitely doesn't fit all when you come to the edge. The edge is one of those environments where you don't always get a 19-inch rack with a lovely air conditioning and a
Mhm.
great way. So the physicality and the portability, those two factors are quite important to us, are really very critical when we come to think about what we're going to deliver into those environments and what each environment needs. Now, you can't make a unique device for everyone. That kind of was where we used to be, where we would spend years creating one device. Technology moves so quickly. We can't afford to do that, and also generally most people fit into much broader patterns of use than they think they do. Everybody thinks they're unique in what they want, but actually when you peel back their requirements, you actually start realizing that there are great common points between them, and also they can make some degree of compromise where they need to ensure that actually they can start building on technologies that maybe exist rather than just reinventing for I need it 1 centimeter less, or I need it a little bit over here. One of the big factors we put into that is actually from a design perspective is making our systems both scale depth, width, and height. So actually that kind of then means that we've got a fabric that means that, yes, we've got standard that we'd expect. We'd expect we'll have 1U and 2U servers. We'd expect them probably in our world to have half 19-inch or maybe slightly wider objects when they're going into racks or fixed locations. But if somebody says, you know what, I really need it to be 625.1 deep and it has to be 37 point whatever wide and it's got to be 3.5 high, we can actually take the mechanical fabric of that, and without having to go and design it from scratch, we can build the layers. Lego is often overused in this world we will talk about, but it's a great analogy that people understand, that ability to build from reusable components. We talk about that in software, but actually we've brought a lot of that idea into what we do with hardware, because that means that we can obviously reduce our supply
Mhm.
chain. We can have a more secure supply chain because we have less people in it, but it doesn't mean that we have to stop our innovation when it comes to the physicality and the portability and the composability of those physical objects, which excites me. I know that software is all about all those phrases I used is big in the software development world, but I think we can learn a lot by looking at that when it comes to the physicality as well. And that's one of the main reasons why when Boston introduced us to Solidigm around the EDSF formats of E1 and .S and .L, they were amazing to us because they were new form factors that meant we could do some amazing new things. The big drive for us was density. Our customers needed a high density and the smallest possible footprint. It wasn't so much about performance, but we will get to performance later. And it's maybe an area we can discuss later because Solidigm obviously are pushing performance as well as the physicality. But that was a key factor for us, was understanding how those changes that OCP, Facebook, drove into the world of EDSF to drive those new form factors actually resonated amazingly well with what we were trying to do with some of the composability and some of the ways we were designing our hardware to make sure that we could deliver different densities all the way from a handheld device up to something that now we can get up to a petabyte of storage and an object that you could carry one hand using some of the 60 terabyte E1.Ls that Solidigm launched recently.
You know, it's interesting when you were talking, it just shows that there are so many different design determinants in this space, so many things to think about. The flexibility that you guys have been able to achieve is really impressive. And in one area, I wanted to talk to you a little bit about, you have something called PACE associated with your platforms. And tell me about what PACE is and how it relates to some of the design parameters that we've been talking about.
Yeah, so the key thing, when we started in the rugged world, and we'll come on, there's a few different sort of definitions that we put around rugged, because rugged can be an overused phrase. from different people have different impressions, and we have our own view of what rugged means. But we had a rugged range for a long time, and then we decided that actually we needed to also have a more traditional air range, but we didn't want to just design an air range that was identical to the existing in the marketplace. It needed to draw upon some of those key design factors that were in our rugged system, but actually then delivered with a traditional air cool. So in our rugged system, we're completely sealed units. That means essentially they can achieve high IP ratings. So that's both dust and water ingress up to IP68 if somebody really needs that level of IP protection for those servers, as well as EMC, which is around the way that electrical signals go into our systems and also come out. They can be important in certain locations. When you come to the air range, we're much more likely to be looking at those factors that govern what traditional server people do. So it's about making sure you can achieve good power in terms of AC, DC power for different things. But half 19-inch was critical. We made a big decision early on that we were going to continue to support 19-inch. That came from our rugged world, and the first designs that went into our air range under pace were also half 19-inch. So we ended up with some common factors, and we put pace above both our rugged and our air ranges to ensure that we had some degree of uniqueness to what we were doing, because it's a crowded market. You know, we're a small British company. We need things that are different, because if not, we're just one of many people delivering hardware capabilities out there. So half 19-inch was critical. The ability to be flexible, we discussed that earlier, the mechanical design of how we can flex, and we can now go below half 19-inch and above by using exactly the same design metrics that we've got in both, which gives us that breadth of capability to go from very small deployments up to large ones. Composability, the ability to compose physically our objects, as well as obviously then when you lay Kubernetes or other operating systems on top to allow you then to compose your infrastructure. So for instance, we were one of the first people to do that with Microsoft. We from Azure Stack for a small SME. Not most of the Azure Stack instances out there are done by very large OEMs, but we were fortunate enough to work our way through those tricky paths to find the right person in Seattle to talk to, and they helped to nurture us through that basis. And one of the key things we needed really early on was great storage. These hyper-converged infrastructures at the edge, like the Nutanix and the Azures and the GDCs, they actually need a pretty decent storage infrastructure to allow you to accredit your hardware to be validated. So actually that was one of the key things. And luckily we had already partnered with Solidigm at that stage to use those disks. And not only did we get the densities that our customers needed, we also got the performance metrics that the likes of Microsoft needed for us to get Azure Stack accreditation for both of our Frontier, our rugged range, as well as our air range. So that was a great achievement by our team. It was great that we had the support of Solidigm and Microsoft to also allow us to get to that point, that we were one of the first small companies to be able to go through a pretty torturous testing process. It took 12 months to do the first one. We can now do that in a 4-week cycle, but just to work out the testing tools actually just took about 12 months to even get that information out, because it's not obvious. Maybe that's a good thing. Now we're in the club. I don't mind that, but actually it took us a long time to get into that club to allow us to do it.
Now, I know that storage choices really mattered within these configurations as well, and you decided to partner with Solidigm on these designs. Can you talk a little bit about that?
Yeah, so we were introduced by Boston early on when we were looking for a partnership for where we were going to move to next with our storage. We decided on NVMe very early, and we were using M.2s prior to COVID. But we kind of knew M.2 NVMe was actually going to be phased out. It wasn't really enterprise, even though people like Samsung and people had put the word enterprise in front of some of their M.2s. They weren't really seen by the industry as being enterprise, and definitely not the OCP world. They definitely didn't see M.2s as being as enterprise. So we were looking to see where to go, and from that we were guided to start working with Solidigm. And one of the great things was they were really forward leading with us really early on. They were very supportive, which can be challenging for a British company, small company, to get that level of engagement early. And they also had a roadmap and a portfolio of products that, as I said before, matched exactly our design vision. When we saw the E1.L, we were like, wow, it kind of, if we could have designed our own storage thing, that would have been the thing we would have come up with. So that was great. So that was a big reason early on is to work with Solidigm. And they gave us samples really early. So as part of our R&D cycle, we needed to explore that technology early, and we needed to test it, and we needed to break it sometimes to make sure that we could understand. We never did actually break one, but that was the plan, was to put it in baking ovens, throw it down ravines, and just see what would happen with this new type of capability. Because obviously it was designed for data centers. It wasn't designed at the beginning to be put in a device that could be thrown out of a plane or carried through a ditch or carried off the back of a boat. It wasn't particularly designed for that. Actually, the fact that the technology works amazingly is great, because now we can start putting it into those locations. And we've had devices for 3 years now that have been fully operational in all of those environments, and many I'm never going to be told about. And we've had 0 failures on any one of
Wow.
those E1s, yeah, which is amazing. Prior to that, and N.2s, we would see some, not many, but we've seen 0 failures on any E1.S that's been out in the field now, live operation for 3 years,
That's
which is
amazing.
great. It is.
Yeah.
So from a maintenance point of view, we haven't even had to test them with the benefits of the maintenance with E1s, because we haven't had to maintain them. They just work, which is great.
That's incredible. And given that these devices are deployed in such, it's not like you can just roll out an IT update if a drive goes down. That can be very problematic. It's incredible. Now, I know that density is a really critical topic for a lot of the platforms that you deliver. How has the collaboration gone so far within that perspective?
So we've we started with E1s, that was the key, and we started with our Frontier range, which was rugged, and in that range we were using those days 8 TB. So we were getting 4 times 8 TB in there, which was great at the time. That was way bigger than we were managing to do early on. We scaled that very quickly up to 6 drives of E1s, now up to 15 TB as the industry's moved forward to 15 in the E1 format. And we're just about to deliver our first using the E1.Ls with the 60 TB. And in one of our platforms, we can now get just over a petabyte of storage in a single object that you could pick up one-handed, actually. It's light enough to pick up one-handed and move that around and use that as an object at the edge. So from a density point of view, I actually think we're probably slightly ahead of where our customers would expect, which is quite rare. Normally, they're always asking for more than we can deliver. I would actually say with that 60 TB density of 17 drives, we're probably getting to the point that even they don't potentially see there's a requirement yet for how they're going to use our servers in an individual object to need to go further than that. They may scale those objects up in some sort of converged infrastructure, but getting more than a petabyte in a single object, not yet. We're starting to work with vast data in some of the government contracts. Vast, obviously, by its name, is all about large amounts of data. So we might see in some of those scenarios around healthcare, maybe, as well as in defense and security, we might start seeing where we are pushing that even further. But with the pace of change and where Solidigm's got to already with their technologies, I don't know where we're going to get to, and Connor can maybe give us later, but we're at 60 already. Who
Mhm.
knows where we could be in another year's time? The way that the pace of change goes, we could be even higher than that in the same physical form factors, or even maybe less. I mean, the E3 form factor, which is a big drive that came out of the OCP, we're going to get to that next. We've focused on the E1s because that just generally fits better in our fabrics, but we know E3s are also going to be critical, and that's where the density also might start to go up. We may see the E3s get a greater density point than maybe the E1.Ls and the E1.Ss. So yeah, density is key for us. I think also using CXL, using
Mhm.
disaggregation, some of those ideas, PCIe 5, they're all coming through now. We know we're already delivering systems with the latest Intel 6 chip. AMD have obviously got their latest one out, but Bergamo already, and Sienna already a PCIe 5 with CXL2. So actually
Mhm.
using some of these technologies, we're now not constrained to just the one box where we see storage or even memory. We can now start seeing these things in a much more disaggregated fashion. Now, we know in the commercial world, they're talking about, rack to rack, or even, rack column to rack column, or even across whole places where they want to join these systems up. We have the same challenge at the edge now, maybe not quite the density in the, but we definitely have the challenge of, I can't fit something right next to the thing I want, so I'm going to have to put it over here, or I want to put it over here, because actually I don't want the two objects to be physically in the same place. So I actually want to divorce them away from each other. So I think that those standards are great. CXL is still emerging. It's a great standard, but I wouldn't say being fully embraced. But hopefully, if the hyperconvergers jump on the back of it, like they have on previous technologies, then actually it will start coming down and the cost price will come down, the breadth of vendors delivering those, which means then hopefully come next year, we can start delivering some CXL enabled storage devices with Solidigm, which allows somebody to go from a petabyte even more, but without necessarily having to increase the compute capability every time. So not having to pay more money on RAM and CPU cores just to get their density up, which will be really exciting, I think, if we get to that point.
Alistair, your conversation just reminds me that there is innovation going on every aspect of the platform right now. It's so interesting to hear how the OCP designs are influencing your solutions at the edge, different standards across storage, IO, all having influence on what you can do and deliver to your customers. Thank you so much for being on and sharing all these interesting things about your platforms and what you're delivering to your customers.
Right, thank you.
Connor, we're going to turn to you now. For those who don't know, why don't we just start with the definition of Solidigm?
Yeah, so first of all, Solidigm is a portmanteau of solid and paradigm. So the goal with the company is to be the #1 storage company in the world. We're very, very storage focused. Coming from the legacy of Intel, we come from a platform company, from a CPU company. Now we have a complete focus on data center SSDs and our portfolio in that space. So we're really able to have complete focus on that. You know, some of the things that Alistair mentioned, for example, design those next generation form factors, have a heavy involvement in that NVMe specification, look to build the future and look to pioneer the future. And it's really given us a lot of freedom. And with the backing of SK Hynix as well, we've got the backing of a major, memory and storage partner behind us. So it gives us everything we need to move forward and be that storage company.
It's interesting when you talk to a lot of storage media companies, they talk about what capacities they have, what kind of volume they're driving, and how they're managing inventory with their customers. You don't hear a lot about co-design like what Alistair just talked about. Do you think this is the thing that makes Solidigm different from other storage companies?
Yeah, absolutely. And one of the points that Alistair mentioned early on was about having that human-centered design and kind of focusing on what is it the customer needs and what can they get, benefit and value from, and then designing around that. So if you go in with a sort of technology-first mindset and try and market that technology, it's difficult, and you try and put things where they don't need to be. So that's definitely a unique part of Solidigm. We're very workload driven, so we'd like to look at workloads. We like to look at use cases and environments and think, what are the big environments? What are the big workloads that are happening right now? Where does storage need to be optimal for that workload? And that will inform our roadmap decisions. That will inform where we go on new form factors. That will inform, the next density point we want to hit and how that's going to be supported on those form factors, for example. So yeah, we want to look at the customer base. We want to look at what people are doing with their storage. Help educate them on how to best use it, and get their feedback and use that to design, the next generation of our products.
Now, Alistair described a really cool company in terms of the use cases he's serving in the market, but I know he also makes a great partner for Solidigm. Why is Antillion such a great partner for you guys?
Yeah, so lots of reasons. I think it's very clear from the way Alistair speaks as well that he loves storage, and he thinks a lot about the ways you can kind of push storage forward and pioneer storage, and that's exactly the way we think too, and we love that. We love when customers are storage focused. We love when they want to work with us early on, and when they're excited about new designs and they're excited about new form factors. Just to give an example, the EVSFF form factor, that was heavily designed by the Intel Storage Group, by Solidigm. We wanted to push the industry forward. We looked at what people were using, on a daily basis in data centers today. They were using 3.5-inch. It was based on a spinning disk. It was based on a hard drive. And in the storage industry, some people can kind of focus on things like, the NAND and the controller and things. But we hear Alistair talk about the physicality, the portability, the dimensions of it, how it's best designed outside of those things that are very board level. They're a very storage focused company. And we love that, and we love working with customers who are like that. And yeah, it makes me happy to hear the passion behind the words he's saying as well, because a lot of the challenges that he's facing and a lot of things that he's designing for are things that we have in mind and things that we want to push forward on our side of the fence. So they make a great partner for us, and yeah, we'll continue to collaborate with them and enjoy sharing the latest in our storage designs and innovations.
Now, Connor, a lot of people think about Solidigm drives as being uniquely developed for the data center. What makes them specifically suitable for the edge environments that Alistair shared with us?
Yeah, so there's a lot of considerations with the edge environment. Some of the things Alistair mentioned, they need to be rugged, not in all cases, and that could be kind of a catch-all umbrella term, but rugged, you might see extreme temperatures. You might not be able to operate on them as well as you would in a traditional data center where you've got a lot of engineers behind you. Ultimately, what you need is storage that you can rely on, storage that is, reliable, it's resilient, it won't fail easily. You don't need to administrate it too much. It doesn't require a heavy lift. And one of the things that we kind of focus on, it really at Solidigm is providing reliable storage. What you'll tend to see with the way our storage works is it will remain consistent in performance over a long period of time. So you can't expect, deploying an SSD and a server in, let's say, a very high temperature environment, in an edge environment, and the performance would taper off. That's not the case with our drives, and we design it that way. So you get consistent, reliable performance. The other aspect as well at the edge that's important is about that failure rate. And it's great to hear Alistair talk about no drives failing. Our failure rate is very, very low. We have a very strict target on our failure rate that we design to, and we consistently beat that. We're very proud of that, and that's something that is a core element to the products that we deliver. So really a lot of the unique aspects of the Solidigm product portfolio really match well in that edge environment. And also, in the background with our engineers and our R&D teams, the edge, I can say, is an extremely important workload right now. We've got a lot of people looking at it. We look at ways to design around it and to make our products more reliable, more resilient, and easier to work with as well. Like Alistair mentioned, things need to be simple, and that's core to us as well.
Connor, Alistair talked about being able to scale capacity within different densities. How is Solidigm achieving that, and where is this technology going?
Yeah, so we were first to market with 60 terabyte data center SSDs, and they've been very popular. So we were very excited to bring that to the market. Throughout our kind of history as a company, we have been very proud of the fact that we have had a very, a lot of investment, a lot of innovation in the density space. From 30 terabyte to 60 terabyte and beyond, we don't want to stop. We're not looking at stopping anytime soon. It's been a big part of the NAND we use. So we use QLC NAND, quad level cell NAND, which allows us to get that extra bit in the cell, and that allows us to hit higher density points at lower costs. So it allows us really to push that envelope forward. We want to continue to do that. But in the background as well, when we push that density envelope, we want to keep it within the same power constraints. We want to keep it within dimensions that make sense for the customer. For example, the E1.L form factor is great for high density products. You can fit, like Alistair mentioned, a petabyte in 1 U of space, very small amount of space, with massive density. So it's an area that's crucially important to us. We will definitely be continuing that development in that space. The high density products are, really, really important to us, and something ultimately we're just very proud of, and want to continue developing.
Well, I can't wait to see what comes next from both of your companies. Alistair and Connor, it was a real pleasure to talk to you today. One final question for both of you. I know that we've talked about a lot of solutions on the show from across both companies. Where can folks find out more about the solutions we talked about today and connect with you and your teams? Alistair, you want
Should I go first?
Yeah, sure.
Yeah. I can go first. Well, you can come to our website, which has information about most of what we talked about. Probably more fun, watch some of the videos we shoot. We really enjoy shooting videos. We did lots pre-COVID, and yeah, as we all got shut down, we couldn't go gallivanting around the world. Well, we did some great ones in the Alps, Scotland, Wales. So we did a few during where we were allowed to go locally. We've got Iceland planned So we're doing a big thing around Iceland, taking some of the storage ideas we spoke today and taking them to Iceland in when it's still snowing. So we'll be going with snowmobiles and all the rest of it. So that'll be great for the for that part. And then we're going to Utah. We opened up an office in the US last year, so we want to embrace the US culture as well as bring our products out there and test them. So again, both of those will be have lots and lots of content with us in Solidigm. Solidigm, we're going to support us on both of those. So I would say watch those. You know, as people are much more interested, like we are today, watching and listening rather than just reading lots and lots of stuff. So come and watch those, and they should be fun.
Fantastic. Connor?
Yeah, so of course, Solidigm website, solidigm.com. All the contact information is on there. And of course, feel free to reach out to myself. I love hearing from excited parties. And I'm always happy to talk about storage. Great to hear the passion from Alistair about it as well. And yeah, look forward to any contact.
Well, thanks so much, guys. We at the Tech Arena will be following this space very closely as the edge continues to evolve to meet the most challenging compute environments on the planet. Thanks so much.
Great. Thank you,
Thank you,
Alison.
Alistair. Thanks, Alistair.
Thanks, Connor.